All right, guys, so we're starting chapter 11 today. There's only 3 sections, and it ends with a double quiz, which is worth 4 homework grades. So start paying attention today, and it'll make the next few days a lot easier. Now, we're going to divide monomials today. There's really 2 ways you can do it. I'm going to show you both, and you just pick whichever way you think makes you more comfortable. So I have x to the 5th divided by x to the 3rd. Now, I can write that differently. X to the 5th is really x times x times x times x times x. That's divided by x to the 3rd, which is really x times x times x. Now, all I have to do is remember that I can cancel out things that are on top and bottom. X divided by x cancels, x divided by x cancels, and x divided by x cancels. Now, when I cancel things, it doesn't leave 0, it leaves a 1. So now on the bottom, once those canceled, all I have really is a 1. On the top, I have x times x, which is x squared, over the one that's left, which is actually just x squared. Now the next one is x squared divided by x to the 6th, and we can kind of write it the same way. X squared is really x times x. X to the 6th is x times x times x times x times x times x. So again, I can cancel some stuff out. These x's cancel, and all it leaves with in the numerator is 1. So I have this equals 1 over. Well, I have 1, 2, 3, 4 x's left, so x to the 4th. So when in doubt, write it out that way. It makes it not very bad. Now, there is a rule we can use to this to where we don't have to write that all out. But if you're not comfortable with the rule, feel free to do it the way we just did it. What it says is when dividing, sorry, my thing is messing up. When dividing, golly. When dividing and bases are the same, subtract the exponents, so I may have skipped a little bit there, guys. I'm sorry. It says, what's the rule? It's when dividing. Maybe I should get my pen on. When dividing and bases are the same, and by bases being the same, they mean like x's and x's and y's and y's. When dividing and bases are the same, subtract the exponents, so we're going to subtract the exponents and put the result where the larger exponent is. And put the result where the larger exponent is. So if I take that and I look at the x over x to the 5th over x to the 3rd, I would first look, well, the numerator has the bigger exponent, so my answer is going to be the numerator. And I'd take 5 minus 3, which would give me x squared. Same thing on the other one, x squared over x to the 6th. My answer is in the denominator, and 6 minus 2 is 4, 1 over x to the 4th. Now let's try that on an example. All right, guys, so let's go and do some examples. We're going to start with number 1. I have 10 to the 5th over 10 to the 7th. So first, let's use the rule. Well, it looks like the bottom one has the bigger exponent, so I'm going to have my answer on the bottom. I take 7 minus 5. That gives me squared. Now, since 10 to the 5th was completely canceled out, I put a 1 in the numerator. And then I can actually do this one. 1 over 10 squared is 1 over 100. Now, the other way you could have done that, guys, is you could have wrote 10 times 10 5 times on the numerator, 10 times 10 7 times on the bottom. 5 of them would have canceled. It would have left you 2 on the bottom. Now, number 2 is a little different, and if we split it up into 2 problems, it's a little easier. I'm going to take all my like stuff. I have 15 over 5, and I have n over n. So when you do this, guys, first get your simplified fraction from your numbers. You have a calculator. I don't want decimals. This one isn't. 15 divided by 5 is just 3. Now, if I look at my exponent or my variables, I have n to the first over n to the first. They're both the same. 1 minus 1 is 0, okay? That means really I have n to the 0. Anything to the 0 equals 1. So really over here I have 3 times 1, which is actually just 3. Because if we do our cancellation, the n's cancel out and leaves us with 1. The next one has numbers and things with exponents, so I'm going to split them up. I have my 12 over 4 times my 10 to the 6th over 10 to the 3rd. So I'm going to start with 12 divided by 4. I get 3 times. Now 10 to the 6th over 10 to the 3rd. The numerator has the bigger exponent, so it's going to be in the numerator. 6 minus 3 is 3, and that means this canceled out completely, left me 1. So times 10 to the 3rd. Again, we could put that in our calculators. 3 times 10 to the 3rd is really 3 times 1,000, which is 3,000. But again, you could have written out the 6 tens and the 3 tens and canceled that way. You would have still had 3 tens left in the numerator. Now, we really do need to use our trick here on this last one with the subtraction. I've got 9 over 12, and I've got y to the 4/3 over y to the 1/3. Now, 9 divided by 12, and I do want a fraction. I can take a 3 out of both of those, which leaves me 3 over 4. Use your calculator if you need to. So I have 3 over 4. Now I'm going to make that the division sign a little longer because I don't know where y is going to go yet. But if I look at my y's, the top y has a bigger exponent, so I'm going to put it back up in the numerator. Then I take 4/3 minus 1/3. The denominators are the same, so I subtract the numerators and get 3 over 3, which is just 1. So you can say 3y to the first over 4 or just 3y over 4. Let's go to the next one. Number 5. Again, we want to start with the numbers, but this one has multiple variables too. So I'm going to have negative 7 over 28. I'm going to put a squared over a. I have b cubed over 1b, and I don't have any c's on the top, so it's just 1, and I have c on the bottom. So this one, guys, you're going to have a c in the denominator no matter what. Negative 7 divided by negative 28 gives me negative 1/4. Go ahead and extend that. If I look at a squared over a, the a is going to be in the numerator because it has the bigger exponent. 2 minus 1 equals 1, so it's a to the first. I have b cubed over b, so the b is going to be in the numerator because it's bigger. And I have 3 minus 1 equals 2, so b squared. Now I've got this last c. The 1's not going to change anything on the top, but the c goes in the denominator. So negative 1/4 a squared b squared over c. Number 6. I'm going to start separating again. Negative 12 over negative 20 times r squared over r times s over s squared. Negative 12 divided by negative 20 gives me 3/5. We move to our r's. The top exponent is larger, so it's on top. I have 2 minus 1 equals 1, so r to the first. The s's, the exponent on the denominator is bigger, so it's in the denominator. And again, I have 2 minus 1 equals 1, so s to the first. So 3r over 5s. Move down to number 7. Now, number 7 can be tricky because of the parentheses. This is really 3s times 3s times 3s times 3s over, in the bottom, it's only taking x to the 4th, so 3 times s times s times s times s. Now again here, guys, we can do some crossing out. These 3's cancel, these s's cancel, so do those, and those. So all I have left is 3 to the 3rd in the numerator, and 3 to the 3rd, 3 times 3 is 9, 3 times 9 is 27. Now probably the hardest one today is number 8. I have negative ab to the 7th. Now I'm going to go ahead and take this 7 and multiply it by both of these. Negative a to the 1st to the 7th, you multiply exponents, get negative a to the 7th. B to the 1st to the 7th is b to the 7th over negative a to the 6th. So we have a negative over a negative. Those cancel. Our answers will be positive. I have a to the 7th over a to the 6th. The numerator has a as with the bigger exponent. 7 minus 6 is 1. Then all I have is b to the 7th, nothing to cancel anything out. So the answer is a to the 1st, b to the 7th. Now that's all for today, guys. There's some review questions on the back that we do need to make sure we have, but that'll pretty much get you ready for the quiz. So let's look at those last few questions. Now I was pretty disappointed with number 10. We had one similar to it on the test, and people did not even do the first step, which is distribute over your parentheses. Remember, there's a -1 right here. So 2 times x is 2x. 2 times 3 is plus 6. Then I have my -5 equals. I have 17. -1 times 4x is -4x. -1 times -2 is +2. Now combine like terms. I have 2x plus 1 equals -4x plus 19. Now here's where I lost the most people. I need my x's on one side, my numbers on the other. So I add 4x to both sides. So I have 6x plus 1 equals 19. I subtract 1 from both sides. Come over here. Now I have 6x equals 18. And the last step is divide both sides by 6. And you get x equals 3. Guys, that should not be a problem. If you're having troubles, we really need to talk about it. Now, number 11, the first thing I want to do is try to get x by itself, and I can add 7 pretty easy. I get 28 equals 4 over 9x. Now I'm going to get rid of my fraction by multiplying everything by the denominator, 9. Nine times 28 is 252. The 9's cancel. It leaves me 4x. I then divide both sides by 4. And I got that 63 equals x. Okay, so not very hard problems. You just got to remember how to do it. Let's go on to the last two. Lisa's score for 3 video games were 245, 672, and sorry, let me get that thing out of the way here. Why won't it go away? There we go. And 437 says what would her score have to be in the next game to tie her friend Ann's average score. Guys, to get averages, you have to add everything up and divide it by the number of terms. So she knows the 3 scores, 245 plus 672 plus 437, but I don't know her last game score. It's x. To get the average of that, I'd have to divide by the number of terms, which is 4, and she wants it to be 438. Now, there's a couple of ways you could work this. I'm going to start by getting my like terms together. The 245, 672, 437. If I add those up, I get 1354 plus x over 4 equals 438. To get rid of my fraction, I multiply both sides by the denominator 4. Now I have, and I'm going to come over here, I have 1354 plus x equals 1752. Last step, divide both sides by 1354. And you get x equals 398. So she has to get at least a score of 398 to tie her friend. Now the last one. Renee earns a salary of $220 per week. She receives a bonus of 1.5% for her total sales. What would her total sales have to be if she wanted to make at least $325? So guys, start with what she has for sure, the 220. Plus, we're going to add to that 1.5% of her sales. Well, we're looking for sales, but I can't multiply by 1.5. You have to convert that to 0.015 times her sales. And they want to be at least, so greater than or equal to, 325. So we got a couple little moves here and we're finished. First, subtract 220 from both sides. You get 0.015x equals 105. I divide both sides by 0.015. And you end up with x needs to be greater than or equal to $7,000. So guys, there's some tough stuff there. Those review questions are similar to your homework problems. Make sure if you need help that you're coming and getting it. Good luck.